Assalamu alaikum and welcome to chapter number 11, in which we are going to discuss on file processing. Now, before I start this chapter, why this chapter and why we need file processing? Up till now, in all the chapters from chapter number 1 till chapter number 10, or actually from chapter number 2, from where we have actually started the C programming, we have been storing all the data in variables, and all those variables have been initialized and they have been made inside the RAM or the memory. So as soon as the code is complete, the compiler exits the code, the compiler finishes the return statement of the main function, or return 0 is done, the variables are freed from the RAM or the memory and they are lost. So sometimes whenever we are making a program, we want to make a hard copy of something, or maybe we want to store them to be used again. For example, supposedly I'm talking about something back in 1970s or 80s, when there were banks and computers actually first of all came into bank, and you were actually going to have a digital record. So C language at that time was actually the only high level language at that time. So at that time, they were actually going to have a file processing being done. So they were going to create files. So the reason of having file processing is, or processing here means to actually create, read, write, erase, delete, rename, or something like that. So processing here stands for a lot amount of things, and we are just going to see a table as well. I will show you at the in this part over there. I have bifurcated this part or this chapter into two parts, part 1 and part 2. In part 1, we are going to discuss how we are going to read that file, how we are going to write that file, how we are going to rename that file, how we are going to rewrite that file, or maybe delete, erase it and rewrite it again over there. And then in the second part, we are going to talk about the random access file over there. Up till now, in part number 1, I am going to discuss the sequential file processing. Now, what I mean by sequential file processing, that if you are going to scroll a file, let's supposingly I want to scroll a file. Now, since I am on a MacBook over here, and on a MacBook, supposingly I want to have a text editor. Supposingly the editor here is text edit over there. Now, inside this text edit file over there, supposingly I have a file named over there. Let's say I have my file name Arsalan Rahim, my name written over there. And after that, I have like something, the age of mine. Let's say I have my age written, and maybe I am teaching the programming fundamentals course over there. So it's just a file over there. And in the next line of the file, supposedly I have, let's say, let's say there is Asim Loan over there, and he is like 59 at present, and he is teaching signal and systems over there. So this is the file over there. And in this way, supposedly I add like 39 or 40 faculty members, or how many, whatever 40 members in our department are there, and I write them over there inside this file. And supposedly this file is given to your C language program, and you are asked over there that you are going to actually find out that, okay, what is the chairman actually doing? And supposedly that chairman is somewhere at here, and his name is Abdul Rahman Kashif over there, and you want to find out that, okay, he is like something of 41 age, and whatever subject he is teaching over there. Now, when you want to find it out, you will have to scroll through all the entries over there, which means from this 1, 2, 3, 4, whatever the entries are. I have not written all the entries over there. So you are going to scroll towards that point, whatever that name you are trying to search on, and then you are going to find out, and maybe you are going to search it, and then maybe edit it, and then save it again. So you have to go through all the files. So if you have a very large file, supposedly you are going to go towards the Nadra. Supposedly in the Nadra, you have also a file saved as something like this. Supposedly you have my name over there, since I'm starting from A. So alphabetically they are arranged over there. So I have my name Arsalan over there, and then I have my 35202 dash whatever the number, and then I have the supposedly my age over there, and then maybe there is some name person Bilal over there, and then his CNIC number is also saved over there, and he is a 21 over there. So alphabetically, there are someone is having a name from Z over there, maybe some Zahur or Zahid over there, or some Zara over there. Then you will have to go all through the entries over there. So this type of file processing is called as sequential. And for very long files or very large files over there, this becomes a very difficult and tedious process over there, and it's very, very difficult to search through this. For that purpose, we have a random file procedure as well, or a random access file as well. We'll talk about this in the part 2, but here in part number 1, I'm going to talk about the sequential files where you are going to store the data sequentially, one after the other, and it can be alphabetical, it can be whatever stuff over there. And this time we are going to make the txt file inside your, now since many of you are on Windows, so this means that the file which you are going to create is going to be, or the file is going to be created by your processor. I will show you that. And that file is going to be processed. You are going to rename it. You are going to have some data added. You are going to have some things added over there, maybe erase it and then add some more data. And then you are going to add in each line over there the data. And of course, that is not going to be alphabetically unless and until you want to store it alphabetically. For that, you have to actually create a whole lot of temporary files and all that stuff over there. We will go through that one as well. So this is the overall thing which we are going to do in this part over there, and that is going to be the file processing which we are going to do over there. So this file processing chapter is provided in like 7 or 8 different articles over there from 11.1 to 11.8. In this part, I'm going to discuss from 11.1 to 11.4 over there. And then afterwards in 5, 6, 7, 8, I'm going to case study is going to be done by you. This is actually a banking transaction processing system. That's an example, I guess, also discussed in this slides as well, which I have over here, and from 11.1 to 11.4. So let's start the chapter and I will just go through it. So this is our today's agenda. And so I'm going to do like supposedly like the first 4 topics in this part over there. There is an introduction to the file processing. Files and streams, you already are familiar with the word streams over there. If you remember it, input, output stream, if you want to actually uh, print some data or take some data from the keyboard over there. Of course, just keyboard is there, mouse is not there, because this is not visual C++ or something visual over there. You're not going to use the mouse over there. It's just a keyboard which is going to input the data. How you are going to create that sequential. Sequential means that you are going to have a sequence, just as I told you, that the data is going to be stored sequentially over there. And then how you are going to read that data from the sequential files and then rewrite it over there. And then in the next part, I'm going to talk about the random access file. The name actually tells you that randomly you can access the files based on the bytes or the based on the offset data over there, and how you're going to create those random files just like your CD or DVD or SSD. Because if your computers, the hard disk inside your computers were sequential access file, then supposedly Windows was supposedly at some like a location in the middle of the hard disk, so it will take a lot amount of time to find out. But here your hard disk are not sequential, they are random access files. You have a file allocation table inside it, which is called as FAT32. Those who are computer geeks or those who have a computer background must have an idea that your Windows nowadays it's NTFS over there, but previously it was FAT or FAT32, which was called as the file allocation table. FAT32 was a 32-bit system, so that was called as. So it was a file allocation table. So there are tables allocated over there, and based on your allocation table, your file is stored somewhere in C drive, D drive, E drive, F drive, or whatever. Same is the case for NTFS, a little different system over there, taking a little more of the file allocations over there. We'll talk about that one if this course suggests over there. So we are going to write randomly to the random access file also in part 2, and then reading again from this one. So you are going to include whatever we are going to do in this chapter with all of the data or all the processing which you have done using arrays, strings, or structures, or unions, or enumerations, or something like that. So before delay, we're just going to through this. We are going to just go through the sequential files and all that. So whenever you are going to talk about data, your data is always going to be formed in form of files over there. Now you are also having a course of AICT in parallel with this. So this means that you also have an idea about database. Now those databases are not based on that sequential files over there, but yes, they are based on files over there. You have making tables over there inside your SQL tables over there. So inside your file, you have a record, you have a record 2, and then you have some fields over there, if you remember it. So your data is handled like this one. So your files, in this course, we are going to talk about just files, just randomly giving you that file over there, and that file will be txt. In your Windows, it will be txt format using the notepad over there. So this is going to be permanent data stored inside your drive. Now, one thing very important, if you have stored your file, the C file, which you are going to make it inside your desktop or maybe my documents, so there your compiler should have access to make new files over there. The files are going to be created based on txt format. The extension will be txt. Just like over there, I clicked over there, the in my MacBook over there, the editor was there. So if I want to save this file, so I will be saving this file over there. Supposedly on my desktop, let's say it will be like something like data.txt over there. So it will be added over there. I don't need to add actually txt over there. It will be automatically added as a simple txt document over there. So this will be just added as data.txt file inside. So you have to save it over there if you are going to create it manually. But here our C language compiler, the GCC compiler, is going to create these files on its own, and we are going to just see what are the commands or the functions based on that one. So this is a data hierarchy. You all are familiar with this thing. So up till now you have been making variables and all that stuff. Now this time you are going to permanently store that data on files over there, so that someone else can actually edit that file, or even you can come back and edit that file, and those permanent data files are going to be stored on your disk over there. There remains even after the program ends. They are slower access because they are sequential over there, and they are large capacity depending upon, supposedly you are in a bank and you have like 1 lakh customers, or maybe like 10,000 account holders in your particular branch, or if you are talking about the whole bank, then maybe you have like 10 lakh or 20 lakh account owners over there. So the file will be very large, and for that purpose, for large file, you have random access file. We'll talk to this one in part 2. But at present, the command, just to give you a little idea, is actually going to be called as fprintf. If you want to write down something inside the file, that is going to be, up till now you have been using printf. Printf was to print it on the monitor or the screen over there. Now you are going to use fprintf. F here stands for file, so file fprintf will be, and the parameters inside are 3. Previously, if you remember it, for printf, it was just simply depending upon what you wanted to print with some format specifier and some variables by using the format specifier over there. Here you have 3 different parameters inside this function. The first one is a pointer to the file. I will tell you this one later on. Just like you had a pointer to a variable in the memory, similarly, that file, if it is on a hard disk and you want to open that file, so you have to open that file inside the RAM or the memory. So you have to give a pointer to that file. So whenever we want to access some file, that has to be accessed through the RAM. Remember, you can't open a file directly from a program. You have to take that file, take it inside the RAM or memory over there, or the main memory, and then you are going to have a pointer to that main memory where the start of that file is there, and then you are going to read that file. So here that file is actually a pointer. I will just tell you how that pointer is going to be initialized. Very simple, but just here, this is the pointer, and here this is the format specifier. You can see over there, here you want to write down whatever. So supposingly this is going to be just a format specifier D. So score is a variable, and of course is going to be an integer or unsigned integer over there, and that is going to store inside the file over there, fprintf over there, and still it's going to be stored over there. So this is a permanent data being stored over there, and I will just show you now how this is going to work over there. Then you have a temporary data. I already am familiar with this one. This is stored in the RAM over there. You don't need any pointers or something unless and until you need a pointer. That's a totally different game over there. So they are stored in the RAM, and they are lost when the program ends. It is fast access but limited capacity because of your RAM being just like 4 GB, 8 GB, or 16 GB. But your hard disk can be of like in terabytes or even more than that, or petabytes over there, depending upon. What is a file? You already are familiar. I don't need to go through this very detail. You already know a file is stored on your hard disk drive, the normal hard disk drives being used in your old computers or old laptops. Then you have the solid state drives, the NVMe drive, which is the fastest one nowadays. Then the USB flash drive, which is also having the same thing, or the memory card, just like your cameras or your mobiles, the memory card, or the cloud storage, which means that you are actually going to store some data on the internet on some other computer online over there, just like a Gmail or a Google Drive account. But here I'm talking about a file being stored locally on your computer in the same folder where your C file is going to be produced over there. The common file types which you can process are in this C is going to be just txt, but you already know the common file types. It can be data files or DAT over there. It can be document files. You already know about DOC, which is the Microsoft Word. Then you have the PDF or the Adobe PDF reader, and then you have the image files such as JPEG, PNG, or RAW, or GIF image, or something like that. But here, when I'm talking about file processing, you have to have a stream. Now, what is a stream? I've talked this one in previously in few chapters back. The stream is a sequence of bytes flowing from the source to a destination. So whenever a program wants data to be taken from an input or maybe an output, it has to have a stream, a sequence of bytes flowing from the source to a destination. So if it's an input stream, it has to come from a keyboard, because our programs are just limited to the keyboard at present. So it's going to keyboard from the program, that's an input stream. And if it's going from the program to the screen, that is called as an output stream. So C language views each file as a sequential stream of bytes. So here you can see this is 0, 1, 2, 3, 4, 5, 6, 7, 8 up till EUF. EUF is the end of file. Just like you had an end of a string by a null terminator, here in file processing, you are also going to have an end of file over there. I will tell you what is that character, or what are the shortcut or the Windows or on the Mac system over there. So you have streams over there, and there are three different streams inside your C language. The first one is the standard input stream. I've just told you previously, you can use scanf or get character. You have used these functions previously in the previous chapters over there. And the library, or the one which you have been using, is stdin. And the output stream, which is going to use for printf or put character, if you want to display something, has been std out. And the combination of this std in and std out is the include statement, which you normally do it in the program over there. If you remember it, that is the stdio.h over there. So include stdio.h is the one which is having that input and output stream over there. Then the last stream, which is very important, and that comes on whenever you have an error, whenever you're having a compiling, or maybe at runtime, there is a compile error. Supposing you are dividing it by 0, or there is some logical error inside your code, then you have a standard error stream as well, that is called the std error. ERR, and that displays the error messages on the stream, and it is used for error reporting. Then I have a file structure. How this file structure, I've already told you this file structure is defined inside stdio.h. So you don't need to do anything. C is a high level language, and it contains every information contained to process a file. But yes, the file has to be a txt file in our case in this chapter. So it includes the file descriptor, position, pointer, etc. And you don't need to know the internal details. Now remember, txt file is the most oldest file created by some Windows or some Macintosh or something like that in 1970s or 80s. You don't need to do something. Now, whenever you need to open a file, you have to copy that file inside the RAM and have a pointer to that. And for that purpose, the simple syntax for that is in caps lock, just write down file is static and a name that is going to be your choice, that is file pointer over there, and that will initialize a file pointer. Now, this is going to initialize which file, I will tell you later on, but at present you can point it to a null over there, just like you pointed a pointer to a null at any given time whenever you're declaring a over there. So file is now the next data type, or actually a file over here, that is going to point to a file structure over there, and it is used to access and manipulate files. By manipulation means that you are going to erase it, write it, rewrite it, or add some data inside it. So each one is going to open a file and needs its own file pointer. So this one, the word file is compulsory, it's a reserved word. And then you have the static, which is a must again over there. And this word is totally dependent upon you, whatever you want to write it down. So this is going to be file pointer over there. And this is built in all the file pointers for the standard input, standard output, or STD error over there. So even if you are going to have an error that is inside the file pointer, the file is not there, or it's not created, or there is an error inside your hard disk over there, it's full, or it does not allow you to create a file over there, because sometimes you put your C language file inside some folder and that doesn't allow you to create a file externally by the C code, then there will be an error as well. We'll see that one as well. So whenever you are going to have a file processing, one thing very, very important over there, a basic file processing means whenever you have done this file pointer, which means a file static. Now you can name this file pointer as simple as f pointer or fptr, totally up to you. That's totally up to you. That is totally on your importance or whatever you want to call it over there. So when you have done this and you have named it according to some file processing over there, then you are going to have the file processing using the functions, which are these ones. Now, in this slide, they are just showing these functions over there. I will discuss them later on in the code over there. The first code is the fputc over there, which is fputc, and that is actually going to put a character, that is a, inside file ptr. What is file ptr? That is the actually the pointer to that file. Now that file has not been still pointed to some file over there. I will just show you in the next slide. In this slide, they have actually given this commands or functions first of all over there. So if you want to write down one character in that file, that is going to be done by fputc. The character is a over there. But if you wanted to do something like that over there, you can do this one inside your this thing as well. If you want to get some character from the file, now this is putting some character, this is getting some character over there. That is fgets from the file pointer. So this is getting some, this is putting some, which means you are reading and writing. There are two different things. And this is equivalent to, if you're doing it on your screen, then you have to do put character. I guess you are already familiar with this. We have used this one in your chapter number 8 a lot. That is put character, and you can print on your A, B, or whatever character you want to print on over there. And this is also equivalent to int ch is equal to get character if you are in taking an input from the user as an input over there, which is the same as fgetc stdin. So instead of file pointer writing on over there, if you just put inside this function fgetc, you put in stdin. Now stdin is the input from the, so it will automatically take, it will not take the file pointer as an input, it will take the input stream, because stdin is for the standard input, and of course in our C language programs, this is the keyboard. So this thing, this command will actually do this thing. Similarly, fputc, previously, if you put it pointer over there, a file pointer over there, then this will be putting inside a file pointer wherever that pointer is pointing out. But if you put in std out over there, because std out is a file stream for outputting the data on the screen, so a will be input output on the monitor or your screen, wherever you are actually trying to put that output over there. So these are two functions over there. This is called as fputc and fgetc. And I guess now you are familiar with this, then you have to just give the file pointer. But yes, file pointer has to be initialized to that file which you want to do. And for that purpose, these are the important functions. The fgets, it reads a line from the file. If you remember, it gets was the file, fgets was the simple function. You can read it from the file. Again, the parameters I will just tell you later on. Fputs, you already seen it over there. Then you have the fputs over there. Then you have the fscanf over there. Then you have fprintf. Then you have fread, and you have fwrite. Now these binary data and write binary data are for the random access files, which we talk about in chapter part number 2 over there. But here in part number 1, we have this 4 functions and this put c and get c over there, which is actually going to read. This is going to read a character. Gets is going to read a line from the file, the whole line up till a \n is encountered. Puts, writes. So this one reads, this one writes, this one reads, this one writes over there. So these are very simple functions, just like the previous one. Just the only thing added is f over there. And remember, these functions are going to have the file pointer added inside your code over there. I will just use some code over there, and you can see what these functions do over there. But before move on to how you are going to have this file pointer initialized to a function, also to a file, sorry, over there, then before that, let's do some self-check questions in the slides. So when program execution becomes, C opens 3 streams automatically. I guess I've already given this answer just now 2 slides back. One is the standard input, standard output, and the standard error stream over there. That is the standard input, standard output, and standard error stream. Then the next question, C views each file as a sequential stream of bytes. As I told you, each file ends either with a end of file at a specific byte number. The answer is the end of file marker, EOF. I will tell you this marker, what is that? And if you want to close a file over there at any given time in your Windows, that is going to be Control plus D or Control plus W. I will tell you just now, and the slides it's going to be there. So this is the second question, which means that C views each file as a sequential stream of bytes, and each file ends either with end of file marker or at a specific byte number. Then what is a sequential access file? I have already told you that you have data from one to the other ones over there, and you have to read each data to reach your specific target. So data is read or written one record after the other. You cannot go after to line number 20 or line number 20,000. So you have to read every 20,000 lines over there, and then you have to go towards that data. That is the disadvantage of a sequential access file over there. So this is just like reading a book from start to finish. Now you can actually flip the pages of a book easily, but still, if you want to go towards supposedly in the middle of the book, you have to go on one page after the other. So you cannot jump to the middle directly. This is simple but slower for larger files. So if you have something, another data for like supposedly all the people in Pakistan, or maybe supposedly just for Lahore, that will be in a crore or more than like 110 million people, or maybe 100 million people over there. So it's going to be very difficult to actually have that data inside one file, and it will be very difficult to have a sequential access file. The easier solution would be a random access file over there, and we'll talk about how this is going to be done. The common uses are the log files, and that will be text documents, the txt files, CSV files. You have already done this one in your Excel course, hopefully. And then the configuration files, whenever you want to store some configuration in your higher courses, you are going to find out that some of the codes or some of the programs, they require some configurations of your settings. Just like if you remember it, in C language compiler, you had that the environment, the system variables being done over there. That was a txt file, but shown over here as a text editor file over there. So that is a configuration file. You have to add the path and the name of that configuration over there. So in that file. So sequential access files are common for these four things. Now, the next thing, very important, that when you are going to have a file pointer, I told you, if you want to have a file pointer, that is file static CFPTR. Now here their CFPTR is totally dependent upon you, whatever name you want to give it. File word is reserved, and this is coming on from stdio.h. Static is a must. This is a pointer over there. CFPTR is our chosen variable name. See here, CF stands for the client's file, because you are actually a client working on that file over there. So you are going to create that file, or depending upon your function which you are going to use, you are going to actually rewrite that file, rename that file, or whatever you're going to do that one. So PTR here reminds us that it's a pointer. It is the best way of having your name of the pointer having that PTR word inside it. So it actually, that your variable is actually a pointer over there. Thus, at present, we are just initializing it to null over there. We're not giving it any file name over there. I will just tell you how that file name is going to be given. So initialize it to null for safety. This is just for safety, that even if you, without initializing it, you just use it, it will be null and it will not be pointing out to any memory address over there. So you are just going to have it for the safe practice, and makes it easy to check if the file opened successfully or not. It prevents using uninitialized pointers, because this is, if I don't put null over there or this equal to mark over there, then this is uninitialized. So, and it can be having a garbage value. So I don't want that garbage value, because it can point out to any other file, and maybe it has a memory lock over there. So the C language may be not allowed to go in that memory location, and your program can crash over there at any given time. So it's better whenever you are initializing it to equal to null. And when you have done it, now you want to open a file. Now that file has to be opened using, now when you have done it equal to null, now your CFPTR, just like your any pointer previously, if you remember chapter number 7, you had to do, and the function is called as fopen. The function is called as fopen. It has two parameters inside it. The first parameter is called, inside inverted commas, the name of the file with the extension. The extension is the name after the dot over there. So in C language, the extension is c.c over there. Here, this is txt. So you are going to open this client.txt file over there, and this file is going to be open inside the same folder where your C file, which you are running this code, is placed over there. So if it is on something, a folder inside desktop, or maybe in my documents, so inside that folder, this client.txt file is going to be created. Either it should be there or something like that. Now the second attribute or the second parameter over here is w. Now what this w actually tells is based on this complete list over there, and you can see very closely over there, what does w mean? W means it write down inside that file, and if it creates a new, or it erases existing. So even if you have no file inside that directory where you are actually running this C language code, it will create a new file, or if it is already there, it will erase the previous contents of that file, and it will start writing inside that file. So what this fopen is going to do, fopen is a function which is called as function file open. Brackets inside, you have the name of the file inside inverted commas. inverted commas, you have W. This W is actually going to tell that it's going to write a file inside that folder. And if you just want to read it, the file must exist over there. That is going to be read existing file over there. So these two are R and W. Now there are some other values over there or other modes over there of this fopen command. And let me just go through this one. A here stands for append. You have a file, supposedly you have like something 9,999 entries over there. So if you want to add another entry, then that will be appended, which means right at the end of the file. So if you have like 9,999 entries over there, you want to add some more entries inside it, that will be A over there. The mode will be A over there. Then if you have R plus over there, R plus means that you are going to read and write both. You're not just going to write, you are just going to read and write. So they have two modes at the same time opened over there. So this means that when you are going to access the RAM or the main memory, you are not just going to read it, you are just going to write and in the file as well. So, but for this condition, the file must exist. It's not going to create a new file. It for this purpose, you have to have that file over there inside your folder. Plus, if you have W plus, then you have read and write, and this one creates new or erases existing over there. Just like the previous case over, this was R and W, this is R plus plus. Here, this was read only, this was write only. Here, this is read and write both. W plus is read and write. W here is having creating also or erasing the previous one. So here W plus and R plus, the only difference is this, that for R plus, the file should already exist. For W plus, it will create if it is not there. So it will automatically search it on inside that folder over there. Then A plus, just like append, that was append. Whenever you are adding the plus sign, this means you are going to read and append over there. So in this append writing, A plus means read and append. So it's going to write at the end of that file. Then binary file. Now you still have no idea about the binary file, but binary files are there going to be used for your random access files. That is the second part of this chapter over there. That is going to read the binary files. WB stands for writing the binary file. Now, binary file, just to give you a little idea, that instead of storing strings inside your or numbers inside your file, you are going to store binary data. You are going to convert each data inside binary numbers, maybe 32-bit, 64-bit, whatever, and you are going to save it inside your files as binary numbers. Just all, we will talk about this one in the next part 2. Then AB stands for the append binary file. Just again, the same names, just the same purpose is there, but this is just binary files over there. And then this is RB plus, then this is WB plus, then this is AB plus. So these are for the binary file, which is actually the random access files over there, which we're going to talk in part number 2. And then you have it for R, W, A, R plus, B, W plus, and A plus, which is for the simple sequential access files over there. So here in this one, you have used W. So W is a little better solution. Why? Because if the file is not there, it will create it. If it is there, it will erase it and write down a new file over there. Unless and until you already know that there is a file is there and you want to add some data inside it, then that will be append over there. Then over there, mode W, this is the write mode. It will create a new file. Warning, if it is already there, the file is already there, as I told you, it will overwrite the existing files over there. And the return of this thing, now this is something very, very important. This CFPTR is equal to fpopen, this one, there is going to be a return of this function. And what is that? It returns the file pointer if successful. So now when you have initialized your CFPTR equal to null, and in the next line, or maybe a little after, you write down CFPTR equal to fopen. So inside CFPTR, you are actually going to now have the pointer to that file. So this function is actually good because it's going to open that file, take it inside the RAM, store it somewhere, whatever, depending upon its size over there, and return its memory address to CFPTR. So if it returns the file pointer, this means it is successful. If it returns null, then this means failed. So you have to give a check on this statement in your while loop, that if it is null, this means that the file is not created, not there, or it's a problem over there, some disk is full or some other problem is there. So this is the first check you have to do, because you can't just run the program and you have no idea that your file has been opened and it is writing some data inside it or not. So you have to check on with the while loop. I will show you the code as well just now, and that will see that how this is going to be done. Then afterwards, if I go on, I guess the command is there already. I just was talking about check if the file opened successfully. Now, when you have written this cfptr is equal to fopen clients.txt, the file is clients.txt, the mode is W, which means it's going to write down, it's going to create already. So it's already going to create. So if this thing with this one is equal to null, if this thing is equal to null, then file could not be opened. Now, this is not practically going to be possible. This is never going to run. Why? Because W mode always is going to be creating a file. Now, there may be a problem that it will not be able to create a file if the Windows or you have some restrictions on that folder. That is also possible. But as far as the C language is concerned, if the file is not there, it will try to make a file, write down something inside it, or it will open the file for you to actually write down inside it. So you have to open a file and then write down something inside it. So this is a check over there, and this will be exiting and whatever you want to do afterwards. Else you can write down something inside puts over there that you have file open already. So the file pointer cfptr will now be having the pointer to this file, which is clients.txt, which will be available inside over there. So what might F not open? No permission to create file in that folder, which is also possible because if in Windows you have done some permission over there, plus the disk is full, maybe you have not space over there, then invalid file name. The file name is invalid. Supposedly you have some alphabets or something underscore inside it, which are not allowed over there. The file is locked by another program. Now, this is also possible. Maybe you are running a C compiler, but at the very same time, this file clients.txt is being opened by some other program or maybe some other C language program over there. So this is one. Second thing, path does not exist. Now, here you are just writing down clients.txt and we are assuming that that file is inside that folder where your C drive or C file is there. But it can be anywhere else. Supposedly you are just having your code inside C drive or somewhere on desktop, but you want to access a file in D drive. So that is also possible. For that purpose, you have to give, let me just show you the C, where is that? I guess I have missed it. Maybe it's a little afterwards. The C drive, actually I have missed it somewhere. It should be here somewhere. Okay, yes, I have missed it. Sorry, it can include a path just like this. So instead of just writing down clients.txt, you can write down inside inverted quotes or double quotes over there. You have C colon / data folder, and inside the data folder, it can be D drive, it can be E drive, it can be F drive. So you can have your file taken from some other folder, some other something. So C will automatically go inside that folder drive over there and automatically take that clients.txt file, whatever you want to do out over there. So if you are just putting inside that folder where your C file is there, then you just have to put the clients.txt name over there. Then afterwards, second thing, very, very important, if you have read your file at the end, when you know your input is finished over there, then you have to check on inside that where is the end of the file. EOF here stands for end of file. F in the start, X stands for file, end of file over there. And this is stdin. So this means that you are actually going to have the end of file indicator. And this is set by the operating system when no more data is there. So C file, whenever that txt file is going to be opened, so you are going to write down inside FUF. Here, instead of stdin, you are just going to have file pointer. So this command cfptr will be put over here inside this one, and inside this while loop you are going to do whatever you want to do. So if you are going to read some data, supposedly from that file, you are going to have FUF, and this will be cfptr over there. So this will be returning you either a non-zero if EUF is reached. So it will be a non-zero value if EUF is reached, which means the end of the file is reached. That's why there is a not statement over there. So it will be a non-zero. So while this is not end of file over there, so this will continue to go on. But if the end of file is reached, which means that it will be zero. It will mean it will be zero if more data is available. So it will be zero. So zero not will be equal to one. So it will be while one, the loop will still continue to run when the data is more available. But if it will be non-zero, which means it will be non-zero, you take a negative of non-zero, it will be zero. So this means this loop will be terminated straight away. And then you can tell the program that, okay, your file has been totally read and there is nothing new inside it over there. Plus, next thing, if you are going to take an input from the user and you want to tell it that sorry, you have want to signal the end of file from the keyboard. In Windows, the command is Control plus Z and then enter. And in Mac OS or Linux, if you are working, since I am working on a Mac OS at present, so it will be Control plus D. So these are the command. I will just show you the practical explanation of this one. But if you are on Windows, you have to use Control plus Z and then press enter over there. So this is the first thing. So the last thing inside, if you are reading a file over there and you are putting something inside it, and you are reading some file from over there, then this command is always going to be there inside your code if you are doing some file processing over there. Plus, before you start reading a file, first of all, you have to declare a file pointer and declare it to null. Second thing you have to do it and open a file with whatever mode you want to use. Here I'm using the W1, which is the more easier way. Here you can put in the path of that file as well, which means the C drive / data is the folder inside C drive. It can be D drive as well. It can be E drive, depending upon wherever you want to do it. And I will strongly suggest you to do it for other drives as well and try to do it over there. And then afterwards, when you have done it, you have given the modes and all that stuff. Then afterwards, the first thing you have to do is check that it is null or not, which means that the pointer of the file is null. If it is null, this means that the file could not be opened. There is some error over there, and out of these 5 errors over there, or it is having some pointer to some file inside the memory, then this means then you can, inside this else statement, you can do whatever you want to do over there. Then at the end of this, when you are going to actually close this file, then this will be the end of file fuf over there. And instead of stdin, you will be write down the file pointer over there. Remember, this stdin is the stream for the input if you are taking it from user, and here this is the file if you are reading that file over there. So whatever that file pointer is there, it's going to return non-zero if end of file is reached, and this is going to return false if any data is available. Remember, this is a not symbol. Don't miss this not symbol, otherwise it will be a problem. And if you want to signal EUF from the keyboard, then this is going to be in Windows, that will be press Control plus Z, then enter. And for Macintosh, it will be Control plus D. I will show you on the Macintosh since I am on a Macintosh. Next thing, if you want to now print, when you have opened the file, everything is done. The first thing, if you want to now print it inside it, as I told you, fprintf, just print it inside the file, nothing fancy. File is there, empty file is there. Supposing you are creating a new file with the W mode over there, then you just need to, the first parameter is the file pointer. Next thing, inside inverted commas, the format specifier, or any text you want to add. Here you are adding %d, the account, then %x, the name, and then %.2f over there, which means it's going to be a balance of your account over there. Inside decimal over there, it's going to be a floating number, so it will be balanced. So these variables are there already inside your code, and you want to put this inside the file. So these 3 values will be put inside the file over there, and you will find it out. And comparison over there, printf, you already know, you do it by simple over there. If you are doing fprintf, then you have to give the file pointer first, then the format specifier inside some whatever syntax or text you want to add over there, and then the variable for which you have added the format specifier over there. If there is no format specifier, you don't need to add any variable name over there. And this is equal to, now if you want to actually use this one and you want to actually make this something like this, then this is fprintf std out. Now here, instead of file pointer, if I put std out is that stream, or you can call it as the pointer to that stream over there. So std out will, now this thing and this thing, they both are exactly the same thing. So here it is fprintf, but here the pointer is not given as the file pointer. Here the pointer is given out for the output stream. So it will print it on your screen. But if you print on a file, then you have to give the file pointer, which is actually a file ptr, or if it is cfptr, whatever you want to call it over there. So parameter are, the first thing is the file pointer, where to write. Here in this case, this is file pointer. Here this is the output stream, so it will print on the screen. The second is the format string, whatever you want to format and how you actually want to display it, using some spaces or something like that. And the third thing is the variables to write over there. Then afterwards, if you have opened the file, it's very important, you have written it inside, you have to read it over there, you have to close the file with fclose. And for that purpose, fclose, just like fopen, this is cfptr, what it will do, it will take off the file from the memory, erase it from there, store it inside over there, inside the ssd or hard disk over there. So, and why closing the file? Because it ensures that all data is written to the disk, and it frees the system resources, allows other programs to access the file, prevents data corruption. Because supposedly if it's in the RAM, you don't close it, and supposing there is a light fluctuation or your laptop goes blank, the file will be corrupted. This happens. You have done this in your Word, Excel, or somewhere. If you have opened a file, you're doing some work, and even you are storing it, but that file is being opened inside your RAM, and at any given time, you're not saving it. So whenever there is a crash, your Windows crashes, there is a light fluctuation, the file will be. So this file close or fclose is must over there. If you have done everything you wanted to do with the file, you have to do this one. So if you don't do it, operating system closes it, but programs end, but can cause problem if program crashes, data might not be fully written, and file might be locked unnecessarily. You have seen this thing inside your Word. Sometimes your file is saved, but it is inside some auto recovery mode. That is done by your Windows over there. It saves that file inside its paging memory, and then it gives you the, okay, we have saved it. If you want to save it, then save it with some other name or something like that. So that is also possible. So the best practice is close the file as soon as you are done with it. So I guess just creating the first thing over there, whenever you want to open a file, the first thing is a file pointer, creating it equal to null. Then next thing, cfptr equal to fopen, open the file wherever that file is, and with the mode W, if you are, W is the most important mode if you are creating a new file or appending a new file or something like that. You can use the A mode, you can use the R mode or R plus or whatever you want to use over there. And then afterwards, when you have done it, the end of file is also there, and then fprintf over there. This is about printing it. In the code, I will tell you about how you can actually use the fgets over there, which is the file reading over there, as I told you in this slide, on this one where we are talking about. So we have talked about the fprintf, we have talked about the fputs as well. That will actually just write a line with a backslash n. Fprintf and fputs are the same thing. The only thing is it that the backslash n is already added by default over there in fputs. Then you have the fgets and fscanf. Fgets reads a line from the file, fscanf reads the formatted data from the file. So they are totally different, just like your array reading or something like that. We will talk this one in the code over there. So let's just go on the first code, and I will run that code in front of you. And this is exactly the same code. This is the same file over there. In fact, let's just first of all go through this code, and then I will run this code inside my Visual Studio over there. You can see over there, the first thing is file cfptr is equal to null, file pointer. Then open the file for the reading. If cfptr is equal to fopen and this is equal to null, this means that file could not be opened. So if file could not be opened, else everything is inside it. Remember, if file is not opened, then it will be file could not be opened, and that will be gone. The remaining program will not run. Then afterwards, if it is open and it is not equal to null, then inside the else brackets over there, you have now three variables. One is called as account, one is the name, one is the balance over there. And now you are having printf. Now this is for you. This is for you on your screen. This is not fprintf still, because I have f open. The file has been opened. Pointer is there. Everything is done. Now I have fprintf over there, and inside it I have the format specifier. You can see this is -10. I hope you have gone through chapter number 9, where -10 is here stands for that you are actually having some space from the right end over there, sorry, the left end of the screen over there, and you are putting a string over there. So this is percentage -10s, and then you have the percentage -13s. So account name and balance. There are three strings being printed on your screen over there. So this is the three strings being printed over there. This is having a space 10 from the left side. This is having a space 13 from the extreme one now. And then this is a simple balance being printed afterwards that. Then afterwards, you are reading the first record. Now you are reading it from the file over there. You are reading from the file, assuming that the file has some data inside it. And here you are using fscanf. Now, if you remember your chapter number 8 over there, where we had scanf simply. A scanf was going to read inside some array. Now here, this is file scanf. You are going to read it from a file. The first parameter is going to be cfptr, the pointer to the file. And then afterwards, the format specifier or the formatted data. Here you can see over there, %d account number. This is the account number. So you are going to read that file according to this format. Now your file has to be according to this format. You can see this is %d. So account number is just going to be from the start of the file. So this means if I have this file over there, let me just create a file. So 1, 2, 3, 4, this will be the file over there. And then afterwards, let me just show you on this thing. The next thing after 29 from the left hand side, string will be there, and that will be the name of the account holder. So after some point over there, let's say that will be Arslan over there, and then afterwards, let me just show you. And the next thing will be the balance, and that will be just afterwards a little space over there, and that will be, let's supposingly I have like $1,000 in my account, and that will be a floating value over there. So my data will be arranged something like this. So this will be 4 5 6 7, and I have over there the point is already being added by the notepad file, so I'm not concerned with that. Supposingly there is another person over there, that is Bilal, and it is also having like something $1,000 or rupees inside its account. So in this way, you will be having a file over there, and that file will be 1 2 3 4 4 5 6 7, and similarly like this. Now when you have done this reading, these values are going to be saved inside these variables: account, name, and balance. When you have done this, the first thing you have done it, now you will open the while loop, which tells you that the end of file has been reached. The same thing I told you, that you have to find out the end of file by using this thing, where FUF is the file end of file, and instead of stdin, you will be write down the file pointer. Remember, you're not going to use stdin or stdout, because that is the input and the output stream. Here you want to use a stream from the file pointer. The file is going to send you a stream of bytes, and that is, and if that stream of byte is the end of file character over there, then that is, so for that purpose you have a while loop, and inside that while loop you can see over there you have the file end of file, and inside it you have the same file pointer. So now when you are doing it over there, you have the printf, and now you are printing that file for you, whatever you have read it. Here you have read the first value, you have read the first value, and now you are printing it on your screen. And then in the next statement, you are again reading it for again using the same command. This is the same exact statement over there, copied over there as a second statement inside the while loop. When you have done it, close the loop, go back again. So one line is read, the next line is read until the end of file is reached over there. When you have run all of the files values over there, then you close the file and return 0. So when this program is going to be run over there, the output is going to be something like this. You have account, name, balance, and something like this. So you can see over there, this is the account. And after, I guess the, what was the value 29 over there, you can see over there, this is 1, 2, 3, 4, 5, 6, 7, and whatever the spaces, I guess I can't count the spaces over there. But of course, this is going to be 29 over there up till this point over there. So it will be 29 over there. And not 29, actually, sorry, I'm wrong. This will be 13. This will be 13 over there, not 19. This will be 13 over there from the left hand side. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13. So after 13, this is name written over there. And then afterwards, this some distance, you have the after 10, you have the account, and then you have the name, and then you have the balance over there. So you can see very easily, you have the account, you have the name and the balance written over there. And then when you are printing it, you have the same nomenclature 10, 13, and you have 7.2. Why 7.2? Because you actually want to have all the points in one line. Okay, I hope you have done chapter number 9. This is very important. So if this is 7.2, this means this is 1, 2, 3, 4, 5. So the balance is going to be with the points on one same, because at the end of the file, maybe in the program output, you want to find out that, okay, in this file, how much whole money is there inside your account. Because if that file is having all the account names and all that, so maybe at the end of it, you want to have a total of all the balance in your account or in your branch over there. So please, I guess, go with this thing. This formatting is very, very important. Those who have not gone through chapter number 9, please go through it, and you will find out over here that is, this is fscanf, and you are going the fclose f over there. Very important points of this one, that the fuf is the returns the true only after attempting to read past euf. So this is going to have end of file. If it end of file is going to be there, then it is going to terminate that while loop. Otherwise, it's not going to be. That's why we read once before the loop. So this means you have to find, first of all, do this read, then check on over there. When this is read, it goes on to the next line. So if there was only one entry inside it, it will do that first reading, and then afterwards it will go on and see if that was the only one reading over there, or only one value inside it over there, it will be having the end of file. So this will not go inside the while loop and then close it and return 0. That will be all. So it will be just one file over there. So this one would be, so then if read again at the end of the loop, and this pattern ensures that we don't process invalid data. So I hope this file is clear. I will just show you this file just now over there. And let me just show this file on the Visual Studio Code over there. I guess I have this file over there. I guess, yes, this is the file over there, and clients.txt. Acha, since I don't have the clients.txt file, now this is something very important. I have this example, the same example we have just done over there. But before that, I now want to create that file. Now, one way is I go inside this folder, wherever that is over there, and I create a clients.txt file. Now, I'm going to create that file by using a C language, by using another C language code, and that is this code. And you can see over there, previously in this code, I was using the mode R. I was just reading the file. Now I'm showing you a code, first of all, that is actually going to write down the data which I am going to put it from the user. For example, let's say, again, same file, ptr. I have cfptr is equal to fopen clients.txt w. Now, if this is equal to null, file could not be opened. But here, this is mode W. If file is not there, it will create it and start writing inside it. So what I'm going to do over there, else everything is inside. You can see everything apart from this is inside the else statement. Now, inside the else statement, you can see what is over there. Enter the account name and balance, of course, separated by a space over there. Then enter the EUF to end input. What is EUF? I told you in Macintosh that will be Control plus D. For your Windows, it will be Control plus W plus enter. I want every one of you to do this thing in this part over there, and then we will come on to back onto this one in the second part, and I will show you how you can have other values for your binary file. Then afterwards, it's going to printf percentage s over there with question mark over there. So this is actually going to print this question mark over there for the printf for you. And then I have three variables. One is called as account, other one is called as the character, other one is called as the balance, which is a float value. You can call it a double or float, totally up to you. And now you are having scanf, same scanf input over there. Here you have percentage d for the account number. Then you have the balance. And now you can see over there is no and symbol. Why? Because arrays don't need to give their and over there. They already are a pointer to their names over there, so you don't need to add. Even if you add it, no issues. It will be just a warning, maybe, or even no warning over there. And here, this is 29 length maximum which you can give. Why 29? Because this is a 30 index or 0 to 29 name. So your name should not be more than 29 over there. So it will be storing that name. And then afterward, this is LF for double over there. That is the balance over there. So it will first of all take the input. Now, when it has taken the input over there, now this is very important. When it taken the input from the user, now I start the end of file for stdin. Now I am not reading the file. I am putting the data inside the file. So my end of file character is not going to come from the file. It's going to come from the keyboard. And that keyboard input is Control plus W for my Macintosh, or for your Windows, it is going to be Control plus W plus enter. So what is going to happen? I am now going to, when this command is not reached over there, then fprintf over there, I am going to put inside. You can see the file pointer. Then I have the percentage D. Then I have the percentage S over there. That is for the name. And then I have the point to F. So these three files values are going to be put inside the file. And it will now print f again percentage s question mark over there. So it will be printing that question mark over there, asking me that should I want to end a file or not. Then if it is not there, then it will scanf for different values. Then if this loop runs on, it will continue to add inside the file over there, line by line over there. And let's just run this program, what it does, and does it create a file over there. Now the folder over here is chapter number 11. You can see this file, this folder over there, chapter number 11. And inside this file folder over there, I only have this C language files over there. There is no client.txt file. So when I'm going to run this file now, you will see automatically there is going to be a file created over there. That is going to be, you can see now, just again, it came back over there. There is client.txt file is there, and client.txt file is empty. It has nothing inside it. So now when I'm going to enter the data, now enter EUF to end input. Now I don't want to do anything data. I can just put Control plus W. But here, supposedly I want to enter the data. Let's say my name is Arslan. Oh, sorry, account number. I have to enter the account number first. That will be 1234. My name is Arslan, and I have like something 1000. Then I press enter. Again, it gives me a question mark if I want to have the End of file. No, still I don't want to. I want to add something more. Let's say I want to have 1235, another account number. Let's say this time this is Bilal, and this time he has like something $2,000 or 2,000 rupees over there. He's a little uh, expensive than me, and he has a lot of money inside his account. Again, enter. Again, question mark over there. Now I want to end the file. So what I do on my keyboard, since you can't see the keyboard over there, I press Control plus W. Now for Macintosh, this is Control plus W. As soon as I will put it over there, let me just put it on. This is Control plus. Sorry, this is sorry. I have okay. I don't know why I have my quick point is not working. Let me just open this file. I don't want to open that. Control plus. Okay, I'm not using the right command. I don't know why it's stuck over there. Exactly. Let me just add something more. I guess I have done some mistake while entering. Okay, I guess I'm doing something wrong over here because it should be entering the that is the end of file. Let me just confirm it out. I guess I'm not wrong over there. The control is okay. Sorry. Control plus D. I'm actually using the wrong one. Sorry. My bad. Sorry on that part. Sorry. This is control plus D for me. So I will be now I have added three values. So this will be control plus D. So I have just put control plus D. Sorry, that was my mistake. Control plus W is not there. Control plus D. Please, just for the memorization, remember for Macintosh, this is control plus D for the end of file or from the input stream or from the data from the file. For Windows, this is control plus Z and then enter. Please remember, don't do this mistake just like I was doing it. And then afterwards, now, if I go, the file is done, it has been done. Now, if I go back on the file, you can see the file has been written. The file has been created, and you can see now 1, 2, 3, 4, Arsalan, Bilal, Ahmed, all data has been put on over there. Now, if I run this code again, let's say I run this code again over there, and now this time I add 1, 2, 3, 4, Arsalan, and this time let's supposing I have like $10,000 over there, and now I put control plus D, end of file. Now, if I go back on my file again, now it will be only having that file. Why? Because it deleted the previous content and added the new file. So now if I will run this code again, and let's say I will add, let's say this time I want to add Arsalan, and this time I have like $10,000 over there, and I have 1, 2, 3, 5. I have Bilal, he has also like something $10,000 over there. I have 1, 2, 3, 6, and let's say this is Ahmed over there, and he has like $20,000 over there, and this now control plus D over there, and this is client.txt. Now you have three files. So you are creating a file, or you're opening a file by W mode, erasing it and writing down your own data. Now, this was the code which you have done, in which you have done the reading of the file. Very simply, the only thing which you have to remember is file pointer, checking it is null or not. Then afterwards, you are having the end of file, and the last thing, closing the file. And of course, you have to, if you are to write it down, something like this. Now, going on to the second code, which we have just done on the slide, what you are going to do, you are going to read now. This is R mode. This is R mode over there, which is client.txt, which is already there. Now that file is already there inside that folder. I don't need to do anything. So it's going to read that file. So now let me just clear it over there. Now over here, I have to read this file, and what it's going to do, it's going to print it up till that file is being read. That is CFPTR. It's going to read this file up till CFPTR. That is, the file pointer is not going to point out towards the end of the file. So when I run this file, you will see now it will straight away read that file, and you can see now the M values, account, name, and balance, they are printed. Now, if that file was not there and I run this file, because file is not there, it will be showing me this answer, that file could not be opened. So I have two examples over there. In this example, you are creating a file with that W mode. Here you are now having with the R mode, reading the file and putting it over there. So you have the account name, and balance, and you can have a lot amount of data inside this file over there, and the file is already there. over there. You can manually enter this file as well, but here the easy way around it is by using this first command over there. You are you are writing the data inside the file, and then in the second program, you are actually reading the file and printing that data over there in this file. This is called as file processing over there. And in this file processing, you are first of all making a pointer. Then you are checking if it is null or not. The file is open. Yes, it's open. You are now available to it. If you want to read it, you have to read it. If you want to write it something, you have to write it down. But again, you have to find out that your input stream, whatever your input is not having that control plus D or control plus W. Sorry, control plus Z. Again, I make a mistake. Control plus Z and then enter for Windows over there. So this is the fprintf statement which is being done over there. And after the closing the file, so this was the file we have just done just now. So this was reading the file over there. That was the sample input over there. And now one thing very important, remember thing, as the integer indicating the next byte to read and write, also called the file offset. So if you want to reset to the beginning, supposedly आपने एक पूरी file read कर ली है, you have done the whole rewriting, reading the program over there, and you want to go back to the first start of the program. That command is called as rewind cfptr. It will go to the start of your file, wherever that file is starting. So if your code was over here and you up till the end, your pointer has reached somewhat at here, this line, now you want to make it back. The function is called as rewind cfptr, and inside, so resetting to the beginning, it will move to the byte 0. So if you have the position pointer to, like, supposedly the third line over there, you can go back to the first points over there. That is by this function, that is rewind cfptr over there. And I guess all this has been formulated inside this table over there. You can see over there, you have the user program, which is opening the file. You have the file descriptor over there. It's a 7 position point buffer info. This is the file structure over there. You are opening the file inside the RAM. This is the FCB for clients.txt. And of course, this file is from a disk. That is, of course, your hard disk or SSD disk or USB disk or whatever it's stored on. So this is a simple structure telling you that you are having a program. It's opening the file from the RAM using your file structure over there. You don't need to read what are the file structures over there. You just need to read the data, and you have the functions available, fopen, fclose, and all that stuff over there. So first of all, next thing before going on to the next thing, common file processing errors, logic errors to avoid. Now, I have already tell you that please always check that fopen is not equal to null, because this means that the file is not there, file is not accessible, or there is some problem. Then opening without permissions, that operating system may deny access, because sometimes you have a password on that file. So maybe the C compiler is not going to open that file. So you have to check this one, that there is a permission available for that file. Then opening the file when the disk is full. Now this is also a problem, because if the RAM is still there, but the hard disk or the SSD or the HDD is not there, so it is not going to open. Then using W mode instead of the R plus mode. W discards the existing content. Remember, W discards the existing content. If you use R plus, that is actually read and write. So if you know the file is there, if you are confirmed that the file is there, then use R plus, and you want to add something inside it. You want to add something inside it, then use R plus. Then not closing the file. Please, closing the file, it's must over there. It can cause a data loss or corruption. So always check if file operations succeed. This is very important. Do check null, do check your file over there, do check if it is app open over there, and all these are done. Then you are going to know that the file operations have succeeded, because there is no other way unless and until you go on the file, scroll over there and see whatever file. And after this part one you have done, you have gone through this part, and you please make a file of at least 1000 plus entries. And for that purpose, I will strongly suggest you go back or go on Google Gemini. Now use AI for this purpose, and ask him to generate a file randomly for 1000 entries txt, store inside your C drive, wherever you are storing that file. Make it something like clients.txt or whatever, and over there have some 1000 entries inside that file, and then process that file and print it inside over there. Okay. Then self-check questions over there. Which will be the following statement writes its output? I guess this will Now, since this is std out, this will output on the screen. Remember, here, if it was file pointer, this will be pointing out to the file over there. But here, this will be the standard output device, that is the screen. The notion of a record of file is built into C, that is false over there. C imposes no structure on file. The file which we are using are the Windows file, or the Windows file structure, or the FAT file system, or the NTFS file system. You must create your own record structure. That is totally up to you. A C program administers each file with a separate file structure, of course. So the C program administers each file with a separate. What is the file structure? Here, the file structure is this code. You are seeing this code. This is the file structure. You have the scanf over there, using that percentage D is there. Then you have the percentage 29s over there. The strings comes on over there. Then you have the percentage LF over there. You have the file structure. So data is arranged according to some nomenclature. So that nomenclature is important over there. Then next question over there, when you open a file for writing, fopen warns you if the file already exists. Yes, of course, this is false over there. It fopen discards the file contents without warning. If you open a file for writing, fopen warns you if the file already exists, because fopen is going to open that file. It does not warn you. It does gives you the pointer to that file. So this is false. Fopen discards the file contents without warning over there if it has the W mode over there. Remember, it is W mode that is over there. I guess if this question should be having the W mode inside it. So it would discards the file content without warning. If it is R, then it is true. Okay. So then it will be different over there. Next question, which file open mode corresponds to open an existing file for upgrade, reading and writing? I guess that is R plus. You already are familiar with this thing. RW is something different. U is not any mode over there. W plus is something different. So this is R plus over there. And the answer is R plus. You can see the answer is R plus. You can go to back to that table where I have showing you this thing. Now, when you are reading the file, I guess you have already done this one over there. You are reading the previously stored data, as you have just done, processing the data in batches and verifying the file contents. If you only need to read, open in read mode. Now, sometimes, supposingly you are a cashier in a bank and you have to just see that, okay, this account has this much money. So you are only going to be accessed or given access for read. Only the branch manager has to have that W mode or that R plus mode, which means it can write it inside it. So you will be only given a read mode, or a function for read will be different. A function for write will be different. A function for creating a new file will be totally different. So it prevents accidental modification and it is more secure. So for large databases, you don't need to damage the whole file over there. So you need to have the CFPTR equal to null, like this one. So this can tell you that, okay, the file cannot be opened over there. Then address, we have already used this fscanf over there. When you are reading the file over there, CFPTR over there, you already are familiar with this one. This is exactly the same as scanf. Scanf was from the keyboard. fscanf is using the file PTR. But here inside fscanf, instead of file PTR, you put in stdin. Then this is equivalent to scanf. So this command can be used in for the keyboard as well. The only thing different is this, that for file PTR, you have to use stdin over there. We have already used this fscanf over here in this command. You can see this one here, and here you have used it already. So there is nothing fancy, just a repetition over here in the slides over there. So the parameters of this fscanf is the file pointer, as you already know, the formatted string over there, and the address of variables to store data. Then a simple program which you can see over there. I will just go through this briefly. I don't want to make this part one a little longer because it's getting a little longer, because this was the main basics of the file processing. Here you can see a credit and inquiry program over there, a business problem. A credit manager needs to view customers by the balance type. So he wants to actually see on that how many customers are having zero balance, how many customers are having credit, how many are having a debit over there. So program features, you are going to be having a menu driven interface, filter records by balance type, uses the same data file. There is only going to be one file that is called client.txt, and it demonstrates the file rewind, which means you go back on the first file or data over there. So the key concept being used are the fscanf, the rewind, to start from the beginning, and enumerations. Now, what are enumerations over there? Enumerations have been discussed in chapter number 10. And just for those who have not gone through that, chapter number 1, part 3, I will just go through this one. Enumerations are just like a name given to levels over there. So here you are having enumeration. The name of the enumeration is level. and you have three different values. Now, what are the three different values over there? Low here stands for 0 by default, medium here stands for 1, high stands for 2. So you have made an enumeration in which low stand. Now, sometimes in your course over there, since I have to grade you people, A plus will be having 4.0, A is also going to have 4.0, B plus is going to be 3.7, B is going to be then I guess 3.5, and then B is going to be 3.2 or 3.3, and then similarly. So I can now name based on their numbers equal to a sequence of grading over there. For that purpose, if you have named this enumeration over there, then enumeration level my variable. Now, what does this means? That now you have made a variable which is called as my var, and you can name it equal to either low, medium, or high. Now, when you are going to make it equal to medium, so whenever you are going to use the variable my var, it will automatically write down 1 over there, because enumeration means that you are just like here in your Gregorian calendar, you have from January to December, you have January, February, March, April, May, June, July, August, September, October, November, December. So you know January is equal to 1, February is equal to 2, March is equal to 3. So if you want to make an enumeration months, you have January, you have February, but here, since by default it starts from 0, you know January starts from 1, January is given a 1, so you are going to give it January equal to 1, and that case is given over there. You can see over there, I will just show you that enumeration that is shown over there. You can in fact, let me show where is that enumeration for that one. In fact, let's just go with this one. You have the enumeration day, you have month, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and enumeration day today is equal to Wednesday. So this means this is going to be Monday is going to be 0, Tuesday is going to be equal to 1, Wednesday is going to be 0, Thursday is going to be 0, 1, 2, 3, 4, 5, 6. But if you want to have Monday equal to 1, then for that purpose, you will have to write down using something like this over there. So let's just say, let me just give you an example over there for this case. I will show you this one, because this enumeration is discussed in chapter number 10. And over here, I have this one. Let's say I have this one Monday, Tuesday, Wednesday. And I'm just putting these string lines, 4 lines over there so that I can have actually. And I have Monday equal to 1. Now, when I've done this thing, sorry, I have put control plus S over there. So when you are putting this enumeration equal to 1 like this, and now you have the variable day. Day today is equal to ved, because you are using the type def command over there. So day today, now you can use the day just like for type def. So this is day today. Today is that enumeration, and you have made it equal to Wednesday. So if today is equal to Wednesday, it is Wednesday. And at the same time, you want to create, or you want to print, supposingly you have to print supposingly percentage D over there. I guess this is going to be the percentage D. And here I want to print Wednesday. And this is going to be, I guess if I run this thing, if I'm not wrong, this will be, you can see what is printed. So Wednesday is taken as, because this is 1, 2, 3. So I have started my one day equal to 1. So Tuesday, Wednesday would be 3. So if I had started this from 10, supposingly, then this will be 10, 11, 12. Wednesday would be 12 over there. Let's just see, I will show you. So this is a sequence of all. So you can see over there. So similarly, you can define type def enumeration for January equal to 1, February equal to same thing. So this is enumeration over there. So this is an enumeration that you are making variables for a sequence of variables which are in some sequence over there. Plus, you can even have them equal, like supposedly if Monday is equal to 1, you can call, let's say Tuesday is equal to 3. For example, you want to make it, this can also work. But when you are going to make this Monday equal to this and Tuesday equal to 3, then Wednesday will be 4. So unless you make for each and every one. So enumerations are done for making them as a sequence of variables which are in a range of variables over there. Now, coming back to our program, which I'm talking about over there, this program over there has an enumeration over there. You can see over there, you have an options over there. You have an enumeration options. Enumeration options has 0 underscore balance. So if you are going to enter 1, then it's going to tell me, okay, how many accounts have 0 balance? How many accounts have credit balance? That will be 2. How many have debit underscore balance? That will be 3. And how many I want to end the program, that will be 4. So this is an enumeration I have done. So enter the request. 1 is equal to list account with 0 balances, 2 list account with credit balances, 4 list account with debit balances. Debit means they are negative. 4 ends at the end of the run. That the end of the program is there. So enumerations make it more readable code, self-documented, and prevents the magic numbers. So you don't need to actually enter the whole zero balance and all that. You just need to give 1, 2, 3, 4. And when you enter 1 over there, it already take the zero balance over there. Now, that code is shown over there. I will not go through this code over there, and I will ask you to go through this code over there. Now, this is that same code which is done over there, and you can see very closely over there what I've done over there. There is bool should display. There is a function over there, and on the top I have the options over there. And what is being done over there, I have a file pointer. I am opening the file. Everything is being read only. The file clients.txt, which has this data, 3 values over there. And let me just add some data, like 1, 2, 3, 4. And let's say I have another menu, Imran over there, and he has 0.0 balance. So let's see, this is that code over there, because there is going to be a printing of with 0 balance when there is credit balance, and then there is negative balance. So let's say Ahmed has negative balance. Okay, so this is something like this. Now, printf 1, 2, 3, 4, scanf request over there. If request is not equal to end, you can see over there this request, you have to enter 1, 2, 3, 4. If your 4 is equal to end, what is end over there? End we all know is equal to 4 over there, because this is 1, this is 2, this is 3, this is 4. So when this is going to be equal to 4, then it's going to print accounts with 0 balances, or it's going to account with credit balances, or accounts with debit balances. When this is done, then afterwards it prints all that data using again fscanf over here and printing that data over there. So it's again ask the user scanf over there like this. So if I just run this program, you can go through this one yourself over there and go through it, because it's exactly the same thing, the reading of the file. So it's asking me list the account with 0 balances 1. So you can see now Imran is printed. So it's only printing that particular over there from the file. It's again reading it, and that is being done by this command over there. If should display request comma balance. Request is the option, whatever you want to do it. And based on the request option over there, option is equal to 0 balance, option is equal to credit balance, option is equal to debit balance over there. So based on whatever you are talking about, 1, 2, 3, 4. So if this is equal to this one and balance is less than 0. So wherever the balance is less than 0, then this means it's credit balance. If it is debit balance, then it is greater than 0 over there. So here, when I'm running this one, let's say I want to now see with the debit balances 3. So you can see now 1000. So debit here, because I'm talking from the bank perspective. So these persons, Arslan and Bilal, they can debit from the account over there. So they have a positive. If it is negative, which means that they have to give back, they have taken a loan from the bank. That's why they are showing as negative. Don't take it as something that this negative is like the bank owns them. I'm talking from the bank's perspective, that the bank has to take $2,000 or 2,000 rupees from Ahmed. But Arslan and Bilal, they have like $10,000 inside their account, and they can take it from it over there. And now I want to close this thing. That will be control plus D. And sorry, I have to have control plus. Okay, I have made it again. Uh, let's see. I guess I have used a wrong command over there. Okay. Maybe let's just, okay. So I have account with, let me just close this. I have closed it. So maybe there is some, no, there is C. Okay, okay. So this is actually not printing it over there. This is just going to, so if I want to end it over there, it's always returning to the beginning of the file. And why beginning of the file? Because when you have gone towards the end of the file, you want to go back, because you have to do the searching again. So that's why the function rewind is being used over there. And again, you are again going to have a scanf over there. Remember, end of file is not going to work over there from the input. You have to enter 4 over there for the end of run. When it's end of this, that will be the break over there. That will be the command will be entered. Why? Because there is a statement over there. Where is that statement of while? That is the, yes, this one. So whenever this is being done, so you are going to have the end of the run over there whenever that is going to be done. So in this way, you can see account with debit balances, account with credit balances. You are seeing this one over there. Kindly go through this file before the part 2 is being uploaded. Kindly go through this one. You will have an idea about what are the enumerations over there and what are this function doing on over there. So this is actually going to return that what are you are actually going to do. The remaining, the reading the file is exactly the same thing, nothing fancy over there. So I will come back in part number 2, where we are actually going to see how this main loop and all that. Just go through this one over there. So whenever the problem with sequential file, just the last line over there, that the problem with sequential file is this, that if you are going to update any file over there, then the text size can be different. Supposedly there was original record of 300 white and 00. Now instead of white, the person has deceased or somewhat, you want to change the name, then now the text is going to be different. Then you will have to put some spaces over there. Now that's very difficult in a sequential file. First of all, you have to find out that text. Then you have to change that text to some other length of text over there. So you have to rewrite the entire file. Now that's very, very difficult. For that purpose, the solution is after this self-check question, the solution is the random access file, which will come on in the next part over there, and we'll talk about this one in detail. Before that, please kindly go through this self-chapter examples, this chapter example number 1, example number 2, and example number 3. And then afterwards, this example number 4, where you are actually just having this dial done. This is actually for the random access file. Just 3 examples are there. Please kindly go through them. And hopefully in part 2, I will give you some questions for your lab number 14 also. I hope you have learned something in this one. It's not difficult. Remember, it's very simple. You just have to remember that you have to make a pointer. You have to make the file open with definite mode RW or R plus or whatever you want to do it. Then you want to find out the end of the file if you are reading something, if you are writing something with using fprintf or something, and that's all. And then afterwards, when you have done it over there, you have to fclose, which means the file close over there for that particular pointer of that file. And that's very simple. And you have to have that file already inside your folder or in that directory wherever you are giving that path in your fopen command. Thank you. And I hope, and any questions, please write down in the comment section of this video.